Now it's time for ITTOs. Let's start with the inputs. Of course, the first one is project management plan. Let's look at its components. Scope management plan. Upon completion of the project, you should know how the formal acceptance of the deliverables will be obtained from the customer. The scope management plan contains those information. Requirements management plan. The requirements management plan describes how the project requirements are validated. Scope baseline. Scope baseline is used to compare the actual results to determine if a change, corrective action, or preventive action is necessary. The second one is project documents. There are 4 key documents in the list. Let's look at them one by one. Lessons learned register. Lessons learned from other projects or the earlier phase of the same project can be an input to improve the efficiency and effectiveness of validating deliverables. Quality reports. As the project progresses, the team may encounter one or multiple quality problems. They need to be addressed, and also you need to ensure that they won't get repeated in the future. Not just the quality problem, but also the recommended process, project and product improvements, corrective actions, including rework, defect, bug repair, inspection, etc. Quality reports is a document where all that are discussed few seconds ago get reported. Requirements documentation. Requirements are compared to the actual results to determine if a change, corrective action, or preventive action is necessary. Requirements traceability matrix. We already discussed about requirements traceability matrix. I hope you remember this picture. The requirements traceability matrix is a grid that links requirements with its origin and its deliverables. The requirements traceability matrix contains information about requirements, including how they will be validated. The third is verified deliverables. Verified deliverables are project deliverables that are completed and checked for correctness through control quality process. The fourth one is work performance data. Let's look at the details. As the project progresses, the project outputs get generated. As a project manager, you should collect all this information. Why? The observation should be measured to understand how well the project is performing. The work performance data can be from any knowledge area of the project, such as schedule, cost, etc. Typically, data is gathered through work execution and passed to the controlling process for further analysis. As the word indicates, data, they are just data points, raw information. These data, raw observation and measurements are collected when the activities are performed. Data are often viewed as the lowest level of details from which information is derived by other process. Let's look at some of the other examples of work performance data. Schedule in progress, actual start and finish date, actual duration, work completed or story points completed in case of agile projects, number of defects, actual cost incurred, delivery status, key performance indicators, technical performance measures, and number of changes requested. All right, now let's move to tools and techniques. The first one is inspection. Let's start with the overview. Inspection is nothing but examination. This is done on the work product to determine if it conforms to documented standards. The result of a single activity can be inspected, or the final product of the project also can be inspected. Inspection may be called as reviews, peer reviews, audits, or walkthroughs. Inspection also used to verify defect repairs. Now in context. In validate scope, inspection includes activities such as measuring, examining, and validating to determine whether work and deliverables meet requirements and product acceptance criteria. Decision making. In decision making, here we have voting. Voting can be used as a decision making process in validate scope. This is used to reach a conclusion when the validation is performed by the project team and other stakeholders. All right, now let's look at the outputs. First, accepted deliverables. Let's look at the overview first. Before making the deliverables to the customer, they are verified by the internal quality team. Upon deliverables meet the specification, they're delivered to the customers. The customer validates the deliverable. This is something we are discussing time and again. I know it's like a broken record, but I do it intentionally so that you remember it. If those deliverables meet the acceptance criteria, then they are formally approved and signed off by the customer or by the sponsor. A formal acknowledgement sent by the customer or by the sponsor upon accepted deliverables, then the project is forwarded to close project or phase. Now in context, the customer validates the deliverables. If those deliverables meet the acceptance criteria, then they are formally approved and signed off by the customer or by the sponsor. The next output is work performance information. First, overview. As an output of project execution, the work performance data gets generated. For example, 40% of the work got completed, the actual duration is 3 days, etc. etc. With this data, you can't make out what's going on in the project. You don't know the performance of the project. The data should become information only then it becomes useful. The data can be analyzed against the project plan. This comparison indicates how well the project is performing. Specific work performance metrics for scope, schedule, budget, and quality are defined at the start of the project as part of the project management plan. During project execution, the project performance data are collected. Performance includes scope, schedule, cost, and other project knowledge area. The measured performance data are compared against the baseline data. The degree of variance indicates not only the project performance, but also indicates if any preventive or corrective action is required. This integrated work performance data helps to make project decision. Now in context, validate scope is done by the customer. The work performance information contains details about which deliverables are accepted by the customer and which are not, and the reason for that. This information is documented and communicated back to the stakeholders. Here, in stakeholders, we are talking about various internal stakeholders such as sponsors, senior management, functional manager, team members, etc. The next is change request. Let's start with the overview. A change request is a formal proposal to modify anything in the project. Implementing those changes can have direct impact on the baseline. Changes may or may not impact the project baseline. Sometimes only the performance against the baseline is affected. Decisions on those changes are usually made by the project manager. Also, change can be raised when issues were found or anything to be improved or anything to be modified in the project. This could result in modifying project policies or procedures, project or product scope, project cost or budget, project schedule, quality of the project or product results. A change request may trigger preventive or corrective action to avoid the negative impact later in the project. Any project stakeholder may request for a change. Every change request must be processed as defined in the change control process. Change requests can be initiated from inside or outside the project. It can be optional or legal or contractually mandated, especially with sellers. Change requests may include defect repairs, corrective action, and preventive action. Let's talk about defect repair, corrective action, and preventive action. You may want to pay special attention to this because in sample examination, there will be multiple twisted questions. First, defect repair. Here, you repair the defective part. You may even replace it as needed. Example, let's say you are manufacturing an automobile component. You notice that some of the components are not as per the technical specification. Obviously, you will not scrap the component directly. You will see the possibility of correcting the defects. If it can be corrected, you take the necessary actions and fix it. Defect repair is also known as correction. Please note it's not corrective action, it is correction. Okay, then what is corrective action? Let's talk about it. Let's go back to our previous example. After doing the defect repair, that is fixing the problem, you see that this particular problem is keep occurring in other components as well. What is the best course of action now? Yes, you find the root cause and fix the problem. By doing it, you ensure that in future this problem is not going to occur, so you need not to fix each and every defective component. Action to eliminate the cause of detected non-conformity and its recurrence is called as corrective action. The next is preventive action. Preventive action is an action that is taken to avoid any anticipated future defects that may appear in the component. For example, let's say you start manufacturing aerospace components which have high precision. You anticipate that some defects will appear on the high precision components even before starting the production process. Therefore, you review all process and procedures and make some changes as needed so that the cause of anticipated defects could be prevented. Actions taken to eliminate the cause of potential non-conformity and its occurrence is called as preventive action. That's the big difference between corrective action and preventive action. In corrective action, after the defect occurred, you go back to the root cause and fix it. That's corrective action. But in preventive action, you eliminate the potential cause of non-conformity and its occurrence in advance. Remember, preventive action is a proactive process. Let's look at another example. In one of the manufacturing line, a component had defect. You fixed it and you delivered it. This is corrective action. There is nothing new here. But later, you found that the problem is consistently appearing. You went back and analyzed the root cause. Here, after analysis, you found that since the machine was new, the operator had difficulties in operating the machine. You sent him to the relevant training. Now everything is back to the normal. Let's reflect what we did so far. For the defective part in the assembly line, you fixed it, it's defect repair. You went back to the root cause. You found that the operator lacks in training. So you sent him for training. So the root cause is addressed. It's corrective action. You haven't stopped there. Going forward, you set up a process so that whenever there is a new machine brought into the assembly line, the relevant operators should go for proper formal training. Here, you took action even before an error occurred because you expected a potential non-conformity. This is preventive action. I hope this clarifies defect repair, corrective action, and preventive action. Now, change request in current context. Validate scope is carried out by the customer. The completed deliverables that have not been formally accepted are documented along with the reason for non-acceptance of those deliverables. Those deliverables may require a change request for defect repair. Don't forget, all the change requests are processed for review through the Perform Integrated Change Control process. The last one is project documents updates. First, lessons learned register. The lessons learned register is updated with information on changes encountered and how they could have been avoided, as well as approaches that worked well for validating the deliverables. Next, requirements documentation. The requirements documentation may be updated with the actual results of validation activity. The last one is requirements traceability matrix. The requirements traceability matrix is updated with the results of the validation, including the method used and the outcomes. All right, that wraps up the ITTOs. Let's move to the next process.